Look at you. Look at me. We are the perfect fit. Can you see our future? I am Avo. I am a smart weeder with a lot more to it. Your field is my canvas. I navigate it with 100% autonomy. I go up. I go down.
With this third prototype, we have addressed the most critical points that we have found in the way to a commercial solution. We are testing the new cylinder, the new sensors, the navigation system, the new robot, because the dynamics have changed a little bit. And that is one hand. And then on the other hand, we are just getting all the data to build the final version of the water stress model.
É extremamente importante para uma viticultura de qualidade nestas zonas vitícolas ter uma boa percepção e uma boa monitorização daquilo que é o funcionamento do estado hídrico da planta. Adaptamos parte dessa informação para validar todo o trabalho que o Vine Scout procura medir no campo para que no futuro possa constituir uma solução que substitua todo o trabalho de medição manual na parcela.
Our navigation system is based on local perception. So the first thing was to get very reliable sensors. So now we have a multi-beam LiDAR with a time of flight sensor and 4 ultrasonic sensors. So all put together give us a very reliable perception of all the vicinity of the robot. Then another important point was the batteries, the source of energy.
Hello everyone. So as you said, Nayo Technologies develops and markets robots for agriculture and viticulture. So TED is the vineyard robot of Nayo. It's a straddling robot, fully autonomous, fully electric, and is dedicated to mechanical weeding under the rows and between the rows.
Go. Good morning, I'm Andrew Bate. I'm the co-founder of Swarm Farm Robotics, and we're an ag tech company based in Queensland in Australia. Joining me online to answer questions tonight is Tom Holcomb, who's one of our engineers and manages our field operations. I'll chat for around 10 minutes and there'll be a further 10 minutes for questions at the end. Just for a bit of background, I'm the CEO of Swarm Farm and I'm also an active farmer running a commercial farm. system called Swarm Connect so that independent developers can release new ag tech on board our robots and deliver new solutions for agriculture. You see, we've had precision ag for a long time, but the difficulty is applying new technology out in the paddock to actually change the field practices that are used to grow our crops. We're not a driverless tractor, we're a new way of farming. We partner with independent developers to release apps and attachments on board our autonomous robots to help solve agriculture's problems. There's no way swarm farming can create all of the applications needed to revolutionise farming around the world. So we're opening up the world of agricultural implement manufacturers to autonomous farming via our robots. Our robots are already working in a lot of industries, including...
Well, you have a question in the Q&A section and in the chat as well. So can you please check?
Excellent. Yep, I can see them coming through now. Someone's asked how much they cost. Our robots go out on a 3-year operating lease. They're 70,000 Australian dollars a year. I'm not sure what that is in euro or US dollars, but I think the conversion rate's around 70 cents to US dollars at the moment. So somewhere around 50,000 US dollars a year to have one. So that's the cost of our machines. We supply them fully backed and supported for the 3-year term. And so the only thing that farmers are responsible for is changing oils and fluids and tyre wear and tear. In terms of prescription maps, we don't create prescription maps. Agronomists and other partners create them. We're just a platform to apply them. Once again, we don't provide spray booms, we don't provide spray controllers. Partners provide those. And so prescription maps are actually done by third-party attachments.
Ben and Leticia Savary, who have been growers of breeders, for 15 years, and they were faced with this problem of flow eggs, and that's how the company was born. We really took that, born from the field, I like to say. We took that very specific problems, and that's how the first robot, our Sputnik robot, was actually conceived. So whatever we do today, we actually have about, I would say, a group of 10 farmers, and whatever we develop or we imagine, we go right away talking with those farmers from the very beginning, even when it's only an idea, to actually confront our idea with the reality of their work and of their constraint. And very early on, we do very simple prototypes, and we put it as early as possible in the farms to test them. I don't like to do R&D in workshops and only with engineers around the table. I think as early as possible it needs to be in the field.